Hi, 我是多娟。I speak English today. Hi, I need to make a science communication. This is a compulsory element in my PhD course. This event is like me as a young scientist. I need to communicate with you, and you are the public. This is an event set by my graduate school, assigned by DFG. Deutsch, Verschwörung, Gemeinschaft. I posted 2 moments at once of biggest Chinese video sharing website, Bilibili and Weibo. I happily collected in total 90 valid questions, and we go through them one by one. In the end, we summarize 10 top questions. Yay! Because other 2 colleagues also need to finish this element, so I invited them to join me and answer these questions.
Hi, I'm Stefan from Munich and I'm a friend of Dong Hao.
Hi, I'm Eleni. I'm a friend of Dong Hao and I'm Greek and I speak a little bit of Chinese.
Hi, my name's Johannes.
Hello, I'm Mette.
This one here. Top 1 question.
So guys, why are so many academia and research groups dumping their garbage into the top journals?
Second question.
How do you detect the magnetic field in space?
Alright, well, do you mean detecting in space while you're in space? Or do you mean detecting electromagnetic waves coming from space? Because if you're actually in space, you basically need what can be described as a very sensitive compass, while if you are on Earth and want to detect electromagnetic field coming from space, then like electromagnetic waves are just light waves. So what you need is a light detector of sorts, basically.
Question 3.
So Eleni, the community is wondering what challenges are facing the development of AI?
So yeah, I think some challenges that are facing the development of AI are probably ethical questions that can be raised from the rapid growth of AI, for example, and it's like very pervasive in society, one might say. Also security and privacy, like it kind of invades people's life, and this is a concern to a lot of people. And yeah, also the quality of the data that can be poor sometimes, and there's no efficient way of controlling the quality. So yeah, I would say that's some concerns actually.
Question 4.
So guys, do you think your research is meaningful?
Yes!
Of course, very confidently, yes.
Yes, definitely.
Sure. And how do you deal with negative emotions when you meet inexplicable problems during an experiment?
Well, I actually am doing what I want to do, and when I don't have a problem, I get problems to solve from my professor, and it all works out really well. There's actual applications, and when I don't have something to work on, I actually make time to work on problems that I find interesting.
I think it's natural to have negative emotions sometimes when you do research, because perhaps there's problems that you cannot solve. And okay, with the camera moving a little. So yeah, there can be frustrations and all that, and this is understandable, especially, I don't know, when you cannot do as much progress as you envisioned before starting. But I think this is kind of the beauty of the process, and at some point when you overcome the obstacle, you talk with other collaborators and so on. So at the end, you reach a point where this is actually solvable, and yeah, I think that's a great feeling, and it makes up for the negative emotions after all. So it's great.
I think I often have negative emotions, and usually I just try different ways to entertain myself, like playing games or go traveling or shoot videos or eat a lot of food, things like that. Sometimes it can help me to relax. Question 5.
So Stefan, this question goes to you. Could you please describe your process of refining your research question of your doctoral thesis?
Thanks, Johannes. So I think this question can vary widely between different fields and also what professor you're working with, or maybe even what country you're working in. I can just say for me personally, my doctoral thesis is going to be a mix of 3 different topics that I've worked in over the 3.5 years of my PhD. And all of those I worked on with my supervisor. And basically we are answering questions from experts in the field or from different companies that brought these questions to us. And my thesis will then be kind of an overarching story over all of these topics that we answered.
Question 6.
So Dong Hao, this question goes to you. As a former energy and power student, how do you think about computational fluid dynamics or solid mechanics in combination with machine learning?
For my bachelor, I studied the computational fluid dynamics, and I think that the fluid dynamics is like we can do that in two ways. The first way is like we use computers to simulate everything to see how fluid moves and everything there. And also there's another way is like we do experiments. And I could only say some like observations. It's like in the Western countries, like, I'm not sure about the US, but in the EU, I find there's many positions promote this kind of areas of the research, like use a computer to simulate the fluids. And even in Japan, there are many positions to do this kind of researches. But as far as I know, that 5 years ago in China, there's not so many kind of the researches, and people more appreciate like experimental researches on fluid dynamics predictions or the experiments. So I think that for the machine learning to combine with like a CFD, then it's very new and a very new trend of these areas, and maybe it's easier to publish in the papers, but in practice, I'm not sure in the future like whether this is valid or not. Question 7.
So now it gets a bit philosophical, I suppose. What, in your guys' opinion, is science? And is it related to religions? And is theology the end of science?
So for me, science and religion are two fundamentally different things. In science, you try to find proofs and figure out the truth of the universe. And religion is more about a belief where people can gather behind. So for me, these two things are just fundamentally different. And none is really the end of the other, but it's just two different paths of understanding the world.
Question 8.
So next question is, how can science actually help social science, arts, or in particular law?
So I think science in the sense of, for example, artificial intelligence or machine learning and the rapid development of these algorithms can actually help social science. For example, psychology, when people have large amounts of data from experiments and they can use some machine learning algorithms to help them draw conclusions, or biology, or like many disciplines where there's a lot of data that's hard to parse. So I think this can help definitely, like science in the sense of computer science, which is the background that we come from. And about arts, I wouldn't say help, like art needs help in a sense, but refine or, I don't know, introduce new aspects. I think this can also contribute to that.
Question 9.
So now the question is, how does AI influence society in the future, and especially if it's a reliable tool to use? I am not sure to what extent it is reliable, at least at this point. So if we look at the recent developments of ChatGPT, I know it's been all over the news, but I think there's also some downside. It is for sure a very capable and helpful tool, but you hear these stories, right, that it starts to basically threaten people, that there's some political radicalization of these chatbots over time. So I think we should be at least a bit skeptical to what extent it can really contribute to society. Also look back in the past, right? The social networks have been, I guess, the last major trend. And I think it's at least controversial if it has really contributed to society and the well-being of society. So I think it has tremendous potential, but we should have some healthy skepticism towards these techniques also in the future and try our best to improve and refine them.
Question 10, the last question.
So guys, can you just talk a bit perhaps about your PhD life, what your research topics are, and how you survive in this entire academic process, and where you see the future of your research with respect to AI?
My research is mainly about integer programming. Integer programming is a kind of method to solve various optimization questions that can appear in real life. And what I do is I look at this method and try to, on the one hand, look at theoretical implications of this method and how to make it better and make it faster. And also I look at real-life problems and try to apply this method to real-life problems, like for instance the placement of charging stations for electric vehicles in cities.
So my research topic is mostly on auctions with financial constraints. So you can imagine if you have like a market and two sides, and then you have buyers on one side and sellers, and the buyers, they have a certain budget. So you can examine this sort of constraints that they restrict what kind of transactions you can have. And also, in general, this is the agenda that we're working on mostly from a theoretical perspective, but we also look at experimental data, and we also want to apply some principles from auctions, like efficient auctions that have some good properties. We want to apply these in some actual environments. And for example, we're looking into biodiversity applications where we can incentivize buyers in order to preserve some lands for biodiversity to grow. So yeah, that's mostly my research in auctions with financial constraints and budget constraints in general.
I do research about the stochastic modeling. It's like in the market that the agents, the users, customers, workers, they will do the events more based on some like statistical process, statistical distributions. Then if the market planners design some policies and design some algorithms, try to match them or set the price of everything there, and what would happen in the market and what's the optimal decision for the market planners. Also, what decision is the most fairest decisions there. This is my research topic.
Yeah, so my research is essentially on electricity market design. So what I look into is wholesale electricity markets. They're centered around auctions. And these auctions you can essentially describe as a big mathematical optimization problem, which is very hard to solve. And we also look at, say, the economic interpretation of the outcome of this problem. So how can we determine a good allocation of electricity? How can we determine meaningful prices in a way that it also contributes to the ambitious future that we have when it comes to electricity, right? The ongoing decarbonization efforts in Europe in particular, some unionization of electricity. And these are, I think, the very interesting aspects I look into in my research.
Okay, so I personally can say that I tremendously enjoy my PhD life, because PhD for me is about solving different kind of problems. And this PhD just gives me this opportunity to work on problems that I'm interested in, basically for a living, and that's what I love and why I'm here.
I think PhD life definitely has some challenges, but it's really rewarding at the end, I would say. So yeah, I think I also couldn't imagine myself doing something else, because I think research is a process that really kind of makes you feel more fulfilled, like in terms of your ambitions and all that. And yeah, I think like especially if you have good collaborators and a good working environment, it's really something to look forward to work every day, and you work in different problems and different topics that you find as challenges, and you solve it, and it's like a really great experience. So yeah, I think it's definitely, it has ups and downs for sure, like when things don't go well with publications and it doesn't go exactly what you envision it to be, but I think at the end it works out for everybody, or yeah, I think it's positive at the end.